Today we're going to talk about relations and functions. Often there is a situation where one variable is somehow linked to the value of another variable. When the value of one variable is related to the value of a second variable, we have a relation. A relation is a correspondence between two sets. We have an example. A relation between states and the number of representatives each state has in the House of Representatives is below. Alaska, Arizona, California, Colorado is related to the numbers on the right. So what is a function? And a function is, let x and y be two non-empty sets. A function from x into y is a relation that associates with each element of x exactly one element of y. To make sense of this definition, let's think of a real-world example. Let's say you're at a zoo and you put a penny into one of those souvenir penny machines. This is actually an example of a function. Here, our original penny that we start with is our input. The machine is our function. And the souvenir penny, the flattened penny, is our output. Now we're going to talk about some different ways functions can be represented. First, functions can be represented as an equation. Instead of a penny for our input, let's have x equals 4. We want to take our input value of 4 and put it into a function, and our function is f of x equals x plus 5. So here we could take the input value of 4 and write it in place of x, so we're going to have f of 4 equals 4 plus 5. 4 plus 5 is 9, and that is our output. We can also represent functions using ordered pairs. Here's our example. Here's a list of ordered pairs: 1, 5, 3, 7, -2, 3, 0, 6. The first value in each of the ordered pair is an input value for the function, and the second value in each ordered pair is an output of the value function. Notice none of the input values repeat. They're all different. Thus, the set of ordered pairs represents a function. Now let's look at our non-example. Look at all the first values. Do any of them repeat? Yes, one repeats, so this is not a function. All right, here's two more ways we can represent functions. Number 3, we can represent a function as a table. Here's our example. We have a column of x values and a column of f of x values. And so if we have a table, we have a list of input and output values. Our input is our x and our output is our f of x. Now, is this a function? Yes, because no input value has two output values, so this is a function. And 4, we're going to talk about graphs. We can also represent a function visually. To do that, we need to graph the function. So here's an example of a function. It's a simple linear equation of y equals x. To test if a graph is a function, we use the vertical line test. The vertical line test says a set of points in the xy plane is the graph of a function if and only if every vertical line intersects the graph in at most one point. So we can just draw random vertical lines on this graph, and I should only be able to intersect the line, the graph, with one point. And I do. So this is a function, yes. And now let's look at a non-example of the graph. We're going to throw some vertical lines on this graph. The vertical lines intersect 2 points. So this fails the vertical line test. So the circle is not a function.